All right, in part 2 of this notes, I actually want to start off by you trying this one on your own. So pause the video, give this one a shot, and then come back when you're done. All right, so this is from the 2013 AP exam, actual question. So it says what's the limit as x approaches 2 of this problem right here? So first thing I'm going to do is I'm going to plug in 2. So I plug in 2, I get 4 plus 2 minus 6 over 2 squared, which is 4 minus 4. And I see I get 0 over 0. That's that indeterminate form. When that happens, we know there's a hole where x is 2. So I want to take out that factor that's giving me the hole and find out what is the function approaching if I take that out. So factoring the top is a trinomial, x plus 3, x minus 2. Remember, the numbers that go in these parentheses, they multiply together to get the last thing, add up to get this number in the middle. Because if I was to do FOIL, like multiply this out, I do first, outside, inside, last, it'd be x squared plus, well, I guess I should say minus 2x plus 3x minus 6. So those numbers add up to get that term, put plus 1x, and they multiply together to get that last one. So that should be a quick little review. You should remember that, hopefully. All right, so, I should have kept that. X plus 3, x minus 2. Now the bottom is the difference of two squares. So that was a little rule where one was a plus, one was a minus. It was 2 and 2. Because those numbers, if I make it a trinomial, the numbers have to multiply to get -4, but add to get 0. All right, so I factored it. I see that this is the restriction. That's a hole. It's called a removable discontinuity. We'll learn that soon. But now if I plug in 2, that would be what the function value is approaching if we took out that hole, which would be 5/4, and luckily I see that, so my answer is D. All right, another technique, if we get the indeterminate form, is to rationalize the numerator. Now you've rationalized the denominator before if you want to you can have a square root on the bottom, but this is a little trick where you rationalize the numerator. So the first thing I'm going to do is plug in 0. I get 0 plus 1, which is the square root of 1. And that's 1 minus 1, which is 0. That's the indeterminate form. So we need to do something else. So I could rationalize the numerator by multiplying by the conjugate. So it's whatever this is, like that's 2 terms, but flip the sign in the middle. And the reason that trick works is now I have a binomial on top times another binomial. And I multiply binomials by doing factoring. So I multiply, or not factoring, FOIL. So I multiply the first 2 terms together. So the square root of x plus 1 times the square root of x plus 1. If I could think, what's the square root of 3 times the square root of 3? That's the square root of 9, which is just 3. So if I'm multiplying the square roots of the same radicand, the square root just goes away, and I can just get straight here to 3. So this is square root of x plus 1 times the square root of x plus 1. That's just going to be x plus 1. So I multiply the first 2 terms together. Now I multiply the outside terms together, the inside terms together. It's -1 times that, so that's going to cancel out in the last terms. So these parts cancel, and I just get x plus 1 minus 1, which is just x. So multiplying that by the top, I would just get 1. But remember, when you're rationalizing, I can't just multiply some number. I can't just multiply the top by something, because that changes the value, right? If I multiply the top by that, I got to multiply the top or the bottom by the same thing. Now this is just multiplying by 1, because a number divided by itself is just 1. So if I multiply the top by the same thing as the bottom, I'm just multiplying by 1. So it doesn't change the value, it just makes it look different. So I have x square root x plus 1 over x. Just multiplying x times both of those things. All right, now, supposedly that's supposed to help us, right? what we're doing now is finding the limit as x approaches 0 of this. So let's plug in 0. Wait, that doesn't look right. There's something wrong. This times this is x plus 1. Boom. Sorry, something doesn't look right. I can't see it. Should probably start over, but I'm not going to. That's x plus 1. Unless it be minus 1. Oh, it should be x on top. So I put 1 on top instead of an x. Y'all might have caught that before I did. Probably did. All right, so let's find the limit of this. Well, it's still an indeterminate form if I plug in 0. But now if I notice, I could factor out an x on the bottom, and I'd be left with this, right? Take those two terms, take out an x. So now the restriction cancels. Now if I just plug in the limit, or plug in 0 now, it's 1 over, plug in 0 there, 0 plus 1 is 1, plus 1 is 2. So that would be our limit. All right, something similar with part B. If I plug in 0, that's square root 5 minus square root 5 over 0. That's just indeterminate form, 0 over 0. Let me clean this page up, give ourselves some room. So when you are watching these videos, the best way to do this is like pay attention to class. That's going to be better. But if you ever miss days, that's what these videos are for. You miss class, you can watch these and not get too far behind. All right, so we need to clean this up. We're going to multiply by some kind of clever one, which is going to be the conjugate. So x plus 5 and square root over, or plus square root 5. So it's whatever this is, but flip that sign. So if it had started out positive, the conjugate would be the same thing, but negative. All right, so we'll multiply this out. I'm going to multiply the first two terms together. I'm just going to keep the limit sign this time. That would be x plus 5. If I multiply the outer and the inner, those are going to cancel. That's the whole point of multiplying by the conjugate, is that middle part cancels. And then the last two terms would be minus 5 over, and I'm going to keep it like this time, x over square root x plus 5 plus square root 5. Okay, on the top, the plus 5 and the minus 5 cancel, and I'm trying to find the limit as x approaches 0 of x over x, all that. All right, what I don't want you to do is don't write this. It's just a bad habit, and I'll do it sometimes, and I want y'all to catch me and yell at me. These are not equal to each other, right? Because the left one has a limit, this one does not have a limit. So you need to have this limit out in front. So be careful with that. Okay, that cancels. And this gives me the limit as x approaches 0 of 1 over square root x plus 5 plus square root 5. Now I can plug in 0. And since I'm plugging in the number, now I can lose the limit sign. So plugging in 0 gives me 1 over 2 square roots of 5, which is our answer. All right, so we're going to learn something called L'Hopital's rule, and we're going to use it all the time. It would actually make these questions easier. It also makes these a lot easier, but we don't know how to do derivatives yet, and the chain rule, and the product rule, and all that stuff. So this is how we tackle these limit questions for now, but later we're going to learn some other techniques. All right, so for now, you kind of need to memorize this. These are some special trig limits, but L'Hopital's rule will help us later when we know how to do derivatives. So this one, if I see sine of x over x, this limit is 1. The limit as x approaches 0, okay, I should say the limit as x approaches 0 of sine x over x gives 1. Same thing if I do the reciprocal. If I have the limit as x approaches 0 over 1 minus cosine, or cosine minus 1, that's going to give us 0. Again, L'Hopital's rule will help us later, but this is just some good little, just practice for now. All right, so we want to find, using these rules up here, what is the limit as x approaches 0 over sine 3x over x? Now, if I plugged in 0, sine of 0 is 0. And if I plug in 0, so it's an indeterminate form, but I can't factor, I can't rationalize. So this is where we use these little trig limits. So I need to make it look like, it looks most like this first one, right? But just a little bit different. The trick is this x, sine of whatever, needs to be the same thing and whatever's on the bottom. So there's a clever trick we can do here. So multiply by 3 on top and 3 on bottom. If I do that, I'm multiplying by 1, which doesn't change the value, but it'll make it look different. So now I have 3 sine 3x. Okay, this blue 3 in front was that one. And on the bottom, now I have 3x. All right, so this is just 1. I'm going to rewrite it. So it's the limit as x approaches 0 of basically, if I can make like 2 separate limits, I'm not going to write it that way. Okay, the limit of the part I circled is 1, so the limit of something that's 1 times 3 would be 3. Another way I could write that would be like the limit as x approaches 0, bring that blue 3 out in front, sine 3x over 3x. This limit is just 1, and then 1 times 3 could give you 3. That's some stuff we'll talk about later too. All right, next one, sine, limit of, as x approaches 0, of sine of 7x over 9x. The trick on this one is it kind of looks like a little bit of both of these. So what I'm going to do is I'm going to just cleverly rewrite this as sine 7x over 1 times sine, times 1 over sine 9x. So if I do that, I mean, this is the same thing, right? Multiply 2 fractions, multiply straight across. So I'm like splitting them up. And now I'm going to multiply the top and the bottom by x. If I multiply the whole top by x and the whole bottom by x, now notice it's not a plus sign, so I don't have to distribute. I can pick like this x, this x is going to go here, and this x is going to go here. Now the limit as x approaches 0 of sine 7x over x plus x over sine 9x. And now I kind of know if I have something like that, this would just be equal to 7 over 9, or like limit of 7. This is 7, right? And this would be 1/9 because it's on the bottom. I could do this extra work that I did out in front, but I don't want to. So it's just 7/9. All right, when we know chain rule, this is going to be so much easier when we know derivatives. But for now, this is just good practice, kind of using some algebra manipulation. All right, last one. Okay, this I'm thinking is going to look something like this right here. Maybe, I don't know. If I plug in 0, though, the cosine of 0 is 1. So I get indeterminate form, and then on the bottom it's 1. Okay, so it's an indeterminate form. I can't just plug in 0. But I might notice here that I can rewrite that, because that's the difference of 2 squares. I can rewrite that as cosine x plus 1, cosine x minus 1. In the bottom, just rewrite it. And now I might see that the cosine x plus 1's cancel. And now I have the limit as x approaches 0 of cosine x minus 1 over x, which is just, I didn't write it down. These are 0. So those are 0. This is supposed to be 1. Again, when we know chain rule and derivatives, this will be a little bit easier, but just good practice for now. If you have any questions, ask me next time I see you in class.